Alright, welcome back to round 2 here with my videos. This week we are simplifying radicals with variables. We're going to be looking at square roots and cube roots pretty much exclusively. So let's start out with square roots here. We know already the square root of x. We already know what it is. It's x. Alright, if we connect last week's stuff, we have the square root of x squared. We can also write it as x to the 2 over 2 power, which 2 over 2 is just 1, so we just get x to the first, or just x. Now, what about square root of x to the 8th? Well, we have square root of x to the 8th that we can rewrite as x to the 8 over 2, and we just divide that 8 over 2, simplify that fraction, and we get x to the 4th. X to the 26th, same deal. X to the 26th over 2, x to the 13th. Now, I don't need to see this step here. We should just be able to jump to the answer. When you're taking the square root of an even number, you're just dividing it in half. So square root of x to the 16th is just half of 16, which is just 8. Half of 84, we get 42. So we have our answers there. Square root of an even exponent should be easy stuff. Going through that part quick. Now, the harder part of this is, what about square root of x cubed? Cubed, the third power, is not an even number, so we can't just cut that in half and call it x to the 1.5. That does not make sense. First thing I want to do is bring back something that we've talked about, square root of 8. 8's not a perfect square, so we broke it up, 4 and 2, took out some of it, which square root of 4 is just 2, and then the square root of 2 was left over inside. We're going back to this. So we're thinking to ourselves, what's the biggest even number that's less than 3? The answer is 2. So I break up the radical. X cubed gets broken up into x squared and x. So square root of x squared and the square root of x. Square root of x squared is just x. Square root of x we can't do anything with, so that is your answer. Couple other odd exponents here. So square root of x to the 9th. We'll break that up. Square root of x to the 8th. We think to ourselves, what's the biggest even number that's less than 9? It's 8. So I go x to the 8th and just x. There's only one x left over to get us back to a 9. So that's why that 1 is just left over. I forgot to mention that in the problem above. So square root of x to the 8th, just cut it in half. X to the 4th. Square root of x is just square root of x. 31. Think to ourselves, what's the biggest even number that's less than 31? It's 30. So I break it up, 30 and 1, because 1x is left over to get us back up to 31. Cut the even 1 in half to get x to the 15th, which comes out. Then I have the square root of x is just x. Same deal on this last one. What's the biggest even number that's less than 107? It's 106. 1x left over to get us back to 107. Cut that in half with the 106 in half, it's 53. So it's x to the 53rd on the outside, square root of x on the inside. Now, notice when we're taking the square root of an odd number, you're always going to be left over with just an x inside the radical. It only takes one extra x or one extra variable to get back to an even number. So you'll always be left over just with one single x. Now, cubes, there's a little bit more going on, but similar ideas. So let's check that out. So cube roots. Similar ideas to what we talked about before. Cube root of x cubed, it can be x to the 3 over 3, which is just x. We'll get some other nice ones here. Cube root of x to the 9th. We go x over 9 over 3. 9 divided by 3 is just 3, so the answer is just x cubed. Notice I gave you a factor or a multiple of 3. Same deal with this x to the 27th. Just do 27 divided by 3, which is 9, and that's just our answer here. When we have multiples of 3, it's easy, just like the square roots. Just divide it by 3, call it a day. Now, moving forward, What about the cube root of x to the 7th? 7 is not a multiple of 3. So we think to ourselves, so instead of thinking about what's the biggest even number, we're thinking about what's the biggest multiple of 3 that's smaller than 7. That's 6. So we break up the radical, cube root of x to the 6th times the cube root of x. It only takes one more x to get back to the 7th. That's why I just put 1 in the second one. I divide the first radical. 6 divided by 3 is 2, so an x squared comes out. And then I have times cube root of x. X is not big enough to come out. Move on to some others. Cube root of x to the 20th. What's the biggest multiple of 3 that's smaller than 18? Or sorry, smaller than 20? It happens to be 18. Now, here's the switch up from what we've looked at. It takes 2 x's to get back to an x to the 20th. 18 is 2 away from 20, so I go x to the 18th and x squared inside here. But the 2 is not bigger than the 3, so it still can't come out. So I do 18 divided by 3 to get x to the 6th. The x squared stays inside because what I already said, it can't come out, it's not big enough. It's not a multiple of 3. Look at the same things moving forward here. 42, biggest multiple of 3 that's smaller than 43, it's 42. It only takes 1x to get back this time. Do 42 divided by 3, it's 14. 1x is left over here. Last one, same deal. I'm just left with 2 x's to get back inside there. Do 66 divided by 3, I get 30. That's not 33, it's 22. Switch that up right now. Get that back. So I got that. 66 divided by 3 is 22, not 33. And then the cube root of x squared is still inside there, so we're good to go. Now, next couple slides, next few examples, we're going to be combining everything here. So let's look. So, first one. I have square root of 25 x to the 4th y to the 8th. We have multiple terms inside the radical, not just single terms like we've been looking at. So I break apart the 3 pieces. I have a 25, I have an x, and a y. So I break those 3 apart and take care of each piece individually. Square root of 25 comes out nice. It's just 5. Square root of x to the 4th comes out nice as well. You just divide it in half. 4 is an even number, so it's just x squared. Square root of y to the 8th, same deal. I just cut that in half because it's an even number, so it's y to the 4th. We happen to be done. That's our answer. Alright, it's nice when everything's are perfect squares. Makes it pretty easy to deal with. We'll look at an easier one too with the cubes. So I got cube root of 27, x to the 18th, y cubed. I break it apart into 3 pieces again. I want to see that. Alright, I want to see you breaking it apart. Cube root of 27 comes out nice. It ends up being 3. Just a heads up. I think I wrote this in the next slide. This first number, when I'm dealing with cubes, it's always going to be a perfect cube. That leading coefficient, I'm going to make sure it's a cube. Squares, not so much. Cubes, though, I'll make sure they're perfect cubes. Cube root of 18, or x to the 18th. 18 is a multiple of 3, so just divide it by 3, get x to the 6th. Cube root of y cubed, 3 divided by 3, just y. That's my answer. So again, it's nice when it's perfect squares and perfect cubes. Next, we're going to have pieces and parts that work out nicely. So we got 12 x to the 7th, y to the 10th. Break the 3 pieces apart. So I broke them apart. Take care of each piece individually. Now, everything I'm dealing with is not necessarily perfect squares. So 12, I need to break up. Biggest factor of 12 that's a perfect square is 4, so I break it up, 4 and 3. X to the 7th, 7 is not an even number, so I break it up. X to the 6th and x. y to the 10th is a perfect square, or even number, so I just leave it as is. I'm going to leave that written. Now I take care of each part individually. Square root of 4, 2. Square root of 3, can't do anything with. Square root of x to the 6, divided in half, I got x cubed. Square root of x, can't do anything with. Square root of y to the 10th, divided in half, we get y to the 5th. Now, last part is just reorganizing. Work's done. Now I just reorganize. Take everything without a radical and put it out front. So out front you're going to see this, 2x cubed y to the 5th. Then put everything in the radical all together. I have a 3 inside and an x inside, so I just put it in together as 3x. That's it. That's your answer. Now notice I don't need these multiplication symbols. If you write them, great. I kind of like them just because they're spacing it nicely in our notes. That's all. Next one. Same idea, just perfect cubes. Notice I give you this hint. That leading coefficient is always going to be, or the constant out front is always going to be a perfect cube with what I give you. So just giving you that hint there typed out. First step, breaking into 3 pieces. That first number is going to be a perfect cube, so just rewrite that one in it. Plug in your calculator if you're unsure what it is. 10 is not a multiple of 3, so I break it up. Biggest multiple of 3, big or smaller than 10, is 9, x to the 9th. Then I got x left over, just 1x. Next one, I have to break up the 14 as well, 12 and 2. Take care of each part individually. Cube root of 64, 4. 9 divided by 3, x cubed comes out. Cube root of x, can't do anything with. 12 divided by 3 is 4. 2 divided by 3 doesn't come out nicely, so I leave it inside. Same organization as before. Anything without a radical goes out front. Anything inside the radical stays inside together. Again, multiplication symbols optional, 100% optional. That's your answer. 2 more just for good measure. I'm going to run through these quickly. I'm kind of running out of time on what I'm allowed to use here. So, first step, break the 3 pieces apart. Square root of 80, not a perfect square, so I got to break it up into 2 pieces. As you can see here, 16 and 5. Watch your combos on one like that. 17, 16 and 1, 31, 30 and 1. Take care of each piece individually now. Square root of 16 is 4, 5 can't do anything with. The even exponents, so 16 and 30, divide them in half. Everything without a radical goes out front. Everything with a radical goes inside. So that's that first one. Square roots are a little bit easier to deal with than cubes. First step, breaking into 3 pieces. Cube root, that leading coefficient, that constant, is gonna be a perfect cube, so you don't need to break that up with cube roots. The variables, though, you may have to break up. 21's a multiple of 3, so I don't need to break that up. 16 is not a multiple of 3, so I got to break it up. Take care of each piece individually. Cube root of 125 is 5. 21 divided by 3 is 7. 15 divided by 3 is 5. Y cube, or the cube root of y, just cube root of y. Notice I didn't have to rearrange. It just so happened to give me the answer right away. So something a little bit different. I am going to post the answers this week just to have yourself check or be able to check yourself on it. So hopefully that helps you out a little bit. If you guys have questions throughout the week, obviously let me know. That's it for this week. Hope you guys are doing well, and I'll talk to you later. See ya.